So, if I were making a first semester alchemy exam in, say, 1500, one of the first questions would be, what are the material, formal, and efficient causes of the formation of the minerals and the metals? Anyone unable to immediately and fully answer that question they'd be dismissed. They'd fail alchemy class. It's just that fundamental to the entire theory and practice of all of Western alchemy. So, a surefire way to misunderstand historical texts of alchemy is to read them as if the physical theories operating in them have basically anything in common with modern physics or chemistry. They don't. In fact, the theory that underlies virtually all of Western alchemy is now so obscure that outside of a few specialists, it more or less doesn't get studied, although that's slightly changing now in the past 20 years, despite its author being one of the most celebrated philosophers and scientists in all of history. That theory, that underlying theory, is primarily to be found in Aristotle's text, the Meteorologica, a work now basically derided as wrong in every respect. It's kind of wrong in every respect. Of course, that's going to bode very poorly for the development of alchemy, but it should not dissuade us from understanding and appreciating the theory, especially in its context. And so let's turn to what was actually, once upon a time, the most unpopular and influential books that Aristotle ever wrote. His work on the meteora, or the phenomena that occur above the earth but below the realm of the stars. And a work without which Western alchemy as we know it would have never developed as it did. If you're interested in magic, hermetic philosophy, alchemy, Kabbalah, or the history of the occult, make sure to subscribe here to Esoterica and check out other content on topics that we have here on the channel, including curated playlists like one on alchemy. Also, if you want to support this work of providing accessible, scholarly, and free content on topics in esotericism here on YouTube, I'd hope you consider supporting my work over on my Patreon. You can take a look at maybe a one-time donation with PayPal, or you can use the Super Thanks option below the video, or you can pick up some of the cool merch that we have over on our channel store, including some pretty cool alchemy merch. But let's turn now to Aristotle's Meteorologica, the theoretical foundation for alchemy and for alchemical transmutation. I'm Dr. Justin Sledge, and welcome to Esoterica, where we explore the arcane in history, philosophy, and religion. In his introduction to the Meteorologica in the Loeb Classics Library translation, Lee, the translator, remarks, quote, that the Meteorologica is a little read work is no doubt due to its intrinsic lack of interest of its contents. Aristotle is so far wrong in nearly all of his conclusions that they can, it may be with justice said, to have little more than passing antiquarian interest. And despite needing some ice for that burn, Aristotle, it's basically true. Even among alchemy and Aristotle readers, the Meteorologica goes profoundly understudied. The first comprehensive study of the text in English was only published in 2014. Prior to that, there were a couple of commentaries written about 200 years ago. And then prior to that, the nearest systematic study was the commentary of the text by Vico Mercatus in his commentary of 1565. And the reason for this is just pretty simple. Aside from the formation of rain and snow, Aristotle's Meteorologica is painfully wrong in virtually every respect. And I'll be honest, I'm a huge Aristotle fanboy. I've literally copied out entire texts of his by hand because I love him. The metaphysics is how I fell in love with philosophy, but it's frankly agonizing. It's embarrassing to read the Meteorologica. And that's true, but it's also maybe a bit unfair. And to understand why this book matters so much, especially for the development of alchemical theory and practice, and why Aristotle gets so much badly wrong, we need to situate the text in the overall landscape of ancient Greek physics. The Meteorologica purports to describe phenomena above the Earth but below the crystalline spheres of the wandering stars. It's a Prague album. This would, of course, include things like meteors, comets, rain, hail, optical effects like sundogs, and even the appearance of the Milky Way up there. But, and this is why this book is so foundational for alchemy, it's also where Aristotle gives his account of how minerals and metals are formed within the earth. As above, so below. And he was kind of doing Hermeticism before there was Hermeticism. And it's going to be there that we're going to be focusing a good bit on this episode, less up there and more down here. But before turning to the theory itself, a bit of context is really needed. The first is that this is a pretty bad theory, but it's at least a theory. At least the Meteorologica does provide us a comprehensive naturalistic theory of what's going on up there. It's sure better than a bunch of rando gods do stuff in the sky. It's not really a theory at all. Now, this is a bug as much as it is a feature in many respects, but we'll get back to that. For Aristotelian science, the tendency in his thinking is towards systematic, comprehensive, and simplifying explanations rather than predictive power or any form of experimental testing. In fact, if you've ever studied Aristotle's physics for any length of time, it's like he's never thrown anything. It's bewildering, the impetus theory. But the Meteorologica was even a bit of an odd text when it was composed. By then, such speculation had long since fallen out of fashion for the kind of moral, what is the good life philosophy introduced largely by Socrates, and of course the metaphysical speculation forward by folks like Plato, and then continued in the academy led by his nephew Speusippus, which also just sort of turned into esoteric mathematics. Aristotle was, in a sense, resurrecting a conversation that had already kind of been ended or abandoned over 2 generations prior to his writing. And that question is, what is the nature of, well, what is the nature of nature? Now, without letting this episode be a giant long thing about Aristotle physics, let's just outline his answer very briefly. For Aristotle, the study of nature was the study of natural causes. The material world, the world around us, is composed of 4 distinct, simple bodies qualified by contrary principles, or properties. However, such matter never exists as such, but it always appears informed in a specific form through myriad means and always for some purpose within the famed system of nature. This is the famed system of 4 causes: the material cause, the formal cause, the efficient cause, and of course, final causation. Everything has a goal, a telos. Matter, or the simple bodies, always exist in 4 qualified forms by their contrary properties. Fire, which is hot and dry; air, which is hot and moist; water, which is cold and moist; and earth, which is cold and dry. Yeah, welcome to like every RPG physics engine. These 4 elements, while distinct by their principal properties — fire has heat, air has moistness, water has cold, and earth has dryness — are nevertheless always set into a kind of dynamic interaction. They're changeable in that they can actually transform into one another if they share a common medium, so fire into air through the medium of heat, for instance, and 2 elements can actually transform into a third by removing a quality or 2 qualities of each, as long as it doesn't, of course, leave behind 2 identical qualities or a contrary quality. You can't leave behind contradicting things like that. So, for instance, fire and water, if they leave behind the dry and the cold, they can give rise to earth. Thus, the system that Aristotle derived is extremely logical. Think about how this maps onto Aristotle's system of the square of opposition in his logic, like in the prior analytics, and its explanatory power of physical change without being radically determinative, like, Democritus and his atoms and void, or worse, making all change into an illusion, a la Parmenides. And it's not purely stochastic, a la Heraclitus with his "you can't step into the same river twice," nor does it give way to an infinite series of transcendentals to explain genera, a la the third man problem in Plato, or at least Aristotle thinks of the third man problem in Plato. From these shifts in the form of matter, underlying materiality remains constant, with its shifts, its changes, always being formal, and that's what's constitutive of change in this system. Individual substances emerge as ratios or proportions of these simple bodies. For instance, a freshly cut tree limb near a fire would reveal water bubbling out, vapor escaping as it heated up. It would eventually combust and leave behind earth as ash. Our bodies contain liquids. They're warmer than the ambient temperature, unless you're dead, and they contain bones, and we aspirate through breathing. Everything, all things from tree limbs to living bodies, are a ratio of those simple bodies, their formal dynamisms produced through some means for some end, the four causes. Thus, the beauty of Aristotle's system. It's powerfully comprehensive. It explains everything from why oak trees produce acorns to why human beings strive for eudaimonia, for human flourishing. But it's precisely this systematicity that's gonna doom the Meteorologica. By the time Aristotle composed the lectures that became the Meteorologica, he had already well worked out his physical theories in texts like the Physics and especially on generation and corruption, along with his theories on the heavens and their movements in Dikilo, on the heavens, unsurprisingly. The only remaining problem were those phenomena that appeared between the levels of the heavens, which he had described with those crystalline spheres, and the earth, the meteora, the space in between heaven and earth. And by developing and applying his system precisely as a system, he'll get everything systematically wrong about virtually everything in the Meteorologica. And that's going to have a huge decisive impact on all Western alchemical traditions and theories, because they're all at some level going to be downstream of the ideas of how the metals and minerals were formed in the Meteorologica. So, given his theory of natural place, that the elements tend toward a position in the universe, Earth gathering at the center and at the bottom, atop which rests, of course, water, and above that, the earth, or the air rather, floating around, and the fire rising all the way to the roof of the universe and gathering in the uppermost realm over there with the sun. Well, the sun is, in Aristotle's idea, dragging along that uppermost air, creating friction, which combusts and communicates heat down toward the earth. That heat, as it lands upon the earth, generates what Aristotle refers to as two exhalations. The vapor, or the moist exhalation of water and air, which drifts upward and comes back down to the earth as water, snow, ice, hail, etc. This is basically what we would recognize as something like the hydrological cycle, and it's the only thing that Aristotle gets right in the Meteorologica. Indeed, this theory of the vapor exhalation was ancient by the time that it had already come to be expressed in Aristotle. It kind of first appears in Hesiod and was basically the singular such exhalation theory in previous theories of nature up to this time. However, Aristotle also seeks to explain the appearance of apparently fiery objects up in the sky. There's stuff on fire up there, comets and shooting stars. And given these are apparently combusting, well, they can't really have their origin in a watery exhalation. The system doesn't do that. So Aristotle turns to the most contrarian philosopher in all of Greek history to find just such a fiery position, and, of course, for a fiery, dry exhalation. Well, you guessed who that philosopher is going to be. Who's about that fire life? It's Heraclitus. Following a variation on a theme from Heraclitus, Aristotle posits that when the heat of the sun strikes the earth, that along with the moist exhalation, another smoky exhalation also rises into the sky, and when ignited, actually becomes heat. And when it ignites, it becomes things like shooting stars and comets. Just in the same way that you can extinguish a candle and then light the smoke back down to the wick and it relights. Aristotle gives that exact example of what he's talking about. One of his great examples that he likes to use. And with these features in mind, the four causes and the two exhalations, the Meteorologica is kind of like logic grinding. It's Aristotle using the theory of the two exhalations in his physical theories to, one, basically show that everyone before him was wrong, aside from Heraclitus, no one even got the second smoky exhalation. This is a bit like what he does in the metaphysics. And he also explains every phenomenon he can think of up in the sky. Rainbows, hail, whirlwinds, shooting stars, thunder and lightning, halos, dog stars, comets, shooting stars, everything. It's all explainable in his theory. And this makes the text a real tour de force in that it is positively comprehensive, it's systematic, and it's consistent with his pretty cherry-picked empirical observations. He even goes in for geometric proofs of the more optical elements that he wants to try to show how they operate in the sky. It's absolutely unsurprising. Absolutely unsurprising. The Meteorologica was the textbook on this topic for basically 2,000 years, and it was among the last elements of the Aristotelian science to be abandoned. It was often among the very first texts that were translated from Aristotle into a vernacular language. For instance, it was the first text of Aristotle translated by Ibn Tibbon into Hebrew because Maimonides felt that it was essential to understanding how God made the universe. Yes, Maimonides argued that Aristotle's Meteorologica accurately described the manner in which God made the universe to work. I mean, that's how decisive this text was. And that was true for pagans and Muslims and Jews and Christians. The Meteorologica, despite its obscurity now, was simply the textbook for understanding the operations of nature, at least up there. And that's where it's going to take us to our impact on alchemy. Because what goes on up there is also going to go on in the earth. Now, just as the vapor exhalation drifted up and fell back down to the earth, so too did the smoky exhalation. Apparently, after burning up in the upper atmosphere, with the whole system actually kind of obeying something like a primitive conservation of matter theory. While most of these exhalations fall upon the earth, they simply get recycled when they fall down upon the earth, some find their way within it. And, as above, so below, the formations of metals and minerals are explained by how these exhalations coagulate within the earth. But, whereas Aristotle is rather exhaustive in other sections of the Meteorologica, for instance, explaining sundogs or halos or rainbows and hail, his discussion of the formation of the metals and the minerals is admittedly cursory. He tells us, in fact, that he's going to come back to this topic more exhaustively in a later book, and we know that he did compose a book or work called On the Metals, which has been lost since antiquity. It's been gone. It's not even clear he even wrote it. In fact, his discussion of the formations of the metals and the minerals at the end of Book 3 and Book 4 of the Meteorologica are pretty radically different even internally, with Book 4 of the text not really even hardly mentioning the exhalations at all. But in the exhalation account, the vaporous and the smoky exhalation enter the earth. They're very fine, and so they can pierce through the earth. And because of the density within the earth, they become compressed, forming something within the earth. In fact, Aristotle uses the metaphor of how frost spontaneously appears on the ground for how minerals and metals spontaneously form within the earth. Now, some of the vapor exhalation evaporates as some of the smoky exhalation burns away, and the ratio of what's left behind between those two exhalations inside the earth becomes the minerals and the metals. More of the smoky exhalation infused substances become minerals, which are neither meltable nor fusible according to Aristotle, such as realgar, ochre, and sulfur. But with more vaporous exhalations added in there come the metals, with iron more on the smoky side of that spectrum. Its ability to oxidize or rust is proof of this smoky mineral-like aspect for Aristotle. But eventually, as more of the moist exhalation is extracted, this eventually would form the metals like copper, tin, but also gold, which Aristotle tells us cannot oxidize, and thus actually contains none of the smoky exhalation at all. Thus, the minerals and the metals are a kind of spectrum, representing how much of the smoky and vapor exhalations become imprisoned within the dryness of the earth, or become compressed by the dryness of the rocks to become congealed, to use Aristotle's language. By the way, that's the answer to the alchemy pop quiz at the beginning of the episode. If you ever meet a would-be alchemist or alchemy expert and they don't know the answer to that question, well, You know in which direction to run. Though, like I mentioned a minute ago, in Book 4, Aristotle seems to forward that the metals and the minerals are just formed by alterations of temperature within the ground of the elements of water and earth. He doesn't even really discuss here, he doesn't really get into the exhalations at all, and it's not even clear how books 1 through 3 and book 4 relate to each other, really. They seem very at odds. These two answers, by the way, are going to get fused, both the exhalation theory and the temperature control theory, and through the process of extreme textural transmission and corruption, they're going to underlie that alchemical obsession with heat control. Though, as I mentioned, just how this process works in fine doesn't really occur in the Meteorologica, and as I mentioned, Aristotle's on metals was lost not long after it was composed, if it was ever written at all. Of course, Aristotle's disciples, such as Theophrastus, would expand upon, but they would never really contradict the Stagirite. In fact, fragments of several ancient commentaries and late classical commentaries on the text survive, like John Philoponus, who was really disliked the eternality of the world, and Olympiodorus, both of which come to mind, again testifying to the popularity of this text even in antiquity. Now, as I mentioned, Aristotle isn't interested in experimentation or even the practical uptake of his theories. There's no predictions even in a book about meteorology. In fact, this is one of the hallmarks of the old science. It's about theoretical explanatory power, not experimental testing or making predictions. That makes it all so foreign to us after the rise of the Baconian scientific method that we all learned in middle school, I suppose. But, of course, there were ancient people very interested in both theory and experimentation, most often in the interest of a specific craft, or even for the production of things like coinage and precious metal assaying. It would be specifically in Ptolemaic Egypt, where traditional indigenous Egyptian metallurgy and jewelry production, very often an extension, by the way, of priestly esoteric knowledge, would come into contact with this powerful new Aristotelian theory found in the Meteorologica, and Western alchemy, as we know it, would be born in that marriage. Indeed, the birth of Western alchemy just is, at some level, Egyptian craft knowledge fused with Hellenistic physics, basically all of which is derivative of Aristotle. Of course, by the Ptolemaic period, indigenous Egyptian metallurgy had already perfected working with a range of metals, especially precious metals, and was also interested in tinting non-precious metals for the production of things like, well, fake gold and even the production of artificial gemstones. The Aristotelian theory gave them the foundation for potentially doing much more than that, to actually convert base metals and minerals into precious metals and gems through art. But how? Recall, minerals and metals are all fundamentally the same matter, just particularized by the ratio of the smoky and the vaporous exhalations, both compressed within the earth. If the difference between gold and lead is simply one of exhalation ratio, temperature control, and some kind of compression, then there is absolutely no theoretical reason why such a process can't be produced at will by art, through artifice. In fact, artisans reproduce natural processes all the time in the world of their crafts. So, armed with the Aristotelian theory of the transformation of the metals and the minerals, and this incredible practical craft knowledge, esoteric craft knowledge of the Egyptian priests, Western alchemy and the dream of substantial transmutation was born. Now, recall when I said that Aristotle's discussion of the formation of the metals and the minerals via the smoky and vapor exhalations were brief. And they even differ, remember, from books 3 and 4 of the Meteorologica. The text is not even itself internally coherent. Well, not only are they brief, but they're also vague. And they're often downright confusing, with modern interpreters still not quite clear what Aristotle's talking about. In fact, the Meteorologica may have just been a series of public lectures where Aristotle was just thinking out loud, kind of making it up as he goes, and the Meteorologica very much reads like that. He kind of starts and stops and moves this way and comes back and changes his mind. They read more like lecture notes, and they're meant to be taken as something like a systematic treatise, presumably something like The Lost on the Metals. Well, that vagueness and that less than coherent nature of the text itself, it's only going to get much worse in the transmission history of the Meteorologica. So it appears that the most influential Arabic translation was going to be made by Yahya ibn Batrik and was made from a Syriac translation of a compendium of Greek texts rather than a direct translation of Aristotle's Greek text. And even when they did make direct translations, they were often incredibly literal at this time. Further, that translation into Arabic is more of a paraphrase than an actual translation. So what we have is a paraphrase into Arabic of a Syriac translation of a Greek mishmash which contained parts of Aristotle's Meteorologica, of which the sections on the metals and the minerals are already vague and only cursorily developed in that text to begin with. Remember, it's probably mostly lecture notes, and the actual text where he discusses it's lost. That text of Yahya ibn Batrik would itself go on to become the foundation upon which Gerard of Cremona's Latin translation would be made, itself made from several corrupt manuscripts and showing evidence of correction. Often these corrections actually just make the text even more corrupt. And it was also the foundation for the Ibn Tibbon Hebrew translation known as Otot Shemayim, the signs in the skies. Though William of Morbik would actually produce a translation of the text directly for Greek in the 13th century, but it circulated among this otherwise complete textual nightmare. The net effect of this translation, transmission, and corruption is that by the time the Meteorologica reached an alchemical lab, the actual theory laid out by Aristotle had become completely garbled and radically simplified. Specifically in the Arab context, the vagaries of Aristotle's theory, along with, again, that textual mess of the manuscript history, will eventually produce a further systematization, clarification, and simplification, exactly the kind of thing that Aristotle would have done in the first place, but in this case, very importantly, through actual, real laboratory experimentation. For the school of Jabir ibn Hayyan, the smoky and vaporous exhalations will be said to produce fundamental mineral and metallic bodies in the form of sulfur and mercury, respectively. However, these never appear as completely distinct in nature. Recall the exhalations are almost always fused, with the exception of gold, which has no exhalation of the smoky exhalation. But as fused into compounds, most fundamentally cinnabar. Now, of course, cinnabar was widely used for a range of things in the ancient world, including for its incredible vivid red color used in things like pigments, but it was also probably the foundation for the Philosopher's Stone. That red in there, I think that is the reason why the Philosopher's Stone is often thought of as red. Why? Because when the roasted cinnabar, or mercury sulfide, it produces mercury vapor, which through distillation can be condensed down into quicksilver via a water bath, and the roasting also releases a very distinct sulfur odor. It smells terrible. And as some of the sulfur gas binds with the oxygen in the water, it also produces atop that water a very thin layer of H2SO4, sulfuric acid, atop which the condensing water in which the purified liquid of mercury drops into the bottom. In this process, the sulfur-mercury theory of the metals was born out of the dual exhalation theory of the Meteorologica and would become the foundation through transmission and corruption upon which almost all alchemical theories would be based until the twilight of alchemy in the 17th century. Even crazy Paracelsus still basically accepted it. He just added salt in there. Again, this development of the sulfur-mercury theory was decisive. It was apparent experimental confirmation of Aristotle's theory, probably again aided by the very fact that this whole transmission history of the text was so incredibly garbled. By the way, a similar discovery would also occur with the cupellation of galena. Galena, recall, is one of the ways that silver occurs in nature, typically with lead. Here, the transformation is via the art, especially using lead as a starting point. Why? The most common form of lead to occur in nature is, as I mentioned, galena, lead sulfide. And to extract the elemental lead, one need only roast it in a common hearth fire. You can roast this in a campfire and extract the lead. Now, what would be obvious to the alchemist would be the smell. As this heats up, it gives off the telltale odor of sulfur. Galena is lead sulfide, after all, and with the liquid lead looking very much like mercury before being quenched and fixed in the water as pure lead. But alchemists working with better fire control realized that with the right kind of furnace, something very strange could happen. If you loaded the galena into a very strong crucible, like these Hessian crucibles, and if they continued to increase the temperature of the galena, the lead would vanish. The lead would vanish. It would oxidize, as we know now, leaving behind a little button of silver, which is very often found in mineral galena. Again, think about all this in terms of the development of alchemical theory. Roasting lead to first give off a mercury-like liquid before it smells like sulfur, eventually leaving behind a little button of silver. The sulfur mercury theory sounds bizarre at first, but it is, at least apparently, borne out through actual apparent experimental experience. Working with cinnabar, working with galena, controlling temperature very accurately, this is how the alchemists confirmed the theory of the exhalations, which gave us the mercury-sulfur theory, and this is how alchemy continued to operate for basically 2,000 years. In fact, it wasn't until 1544, when Georgius Agricola published his De Ortu et Causi Subterraneorum, that Aristotle's exhalation theory, including the sulfur-mercury theory of the metals, came under sustained attack. Of course, in his 1556 De Re Metallica would become the standard textbook on mining. It represented the peak of Renaissance mining and assaying technology, and really represented the beginning of the end of the old Aristotelian theories in all their forms. This is well before Boyle's skeptical chemist, by the way. Even during his lifetime, Agricola began to drop the "al" from alchemia to denote his increasing intellectual break with the theory and practice of transmutation, something that had actually already began probably as early as the 1531 Rector Gebrach der Alchemie, which also at that point militated away from seeing alchemy as a search for the philosopher's stone for, frankly, something more practical, away from the theory of substantial transmutation and to something more even industrial, like the purification of saltpeter, which of course you can use saltpeter to make gunpowder, and that was a surefire way of getting gold. And this would be the first step in the move toward the professionalization of alchemy in Central Europe through the 17th century. All in all, Aristotle's Meteorologica and its theory of the formation of the minerals and the metals lies at the core of Western alchemical tradition in terms of theory and practice. And without a deep understanding of the whole work, at least methodologically speaking, understanding historical texts of alchemy is, I would argue, it's basically impossible. You have to have an understanding of how the meteorological works to understand any of the text of historical alchemy. That's simply no way to grasp what the alchemists are doing, why they make the decisions that they do, how they develop their theories in the ways that they do, how they look for the color changes that they do, or subject matter to the processes that they do using the things that they have access to, like cinnabar and galena and crucibles like these, without a firm grasp of the Meteorologica. There's also just no way to appreciate how tragic the history of alchemy is, given that it was effectively built on a theoretical foundation so utterly flawed that the Meteorologica is now regarded as laughably mistaken on virtually every point Aristotle makes. You can also kind of now begin to appreciate why people in the 19th and 20th centuries basically made up all that alchemy was really just spiritual practice stuff. By then, it was painfully obvious that aside from some development on the secondary technologies that derived from alchemy, Western alchemy labored for 2,000 years under a systematically incorrect theory that was badly translated, then corrupted in its literary transmission for an end goal that was physically impossible. There is no chemical transmutation, unless you have atomic technology. So let's just paper over that with it was all really spiritual because, they used some metaphors sometimes and, they got a lot of cool, weird pictures in there. So spiritual. It's one of the most successful rebrandings in history, if I'm going to be honest. Of course, that rebranding has incredible spiritual value for many people, and that's incredibly important. it's profoundly worthwhile as a spiritual path now. But it doesn't change the fact that nearly all of that spiritual alchemy stuff was basically a rebranding in the end. I mean, I have episodes about actual spiritual alchemy that developed in the late 16th century. Thankfully, interest in the Meteorologica has risen in the past 20 years or so, which is especially important for those of us actually interested in alchemy. The best study in English is Wilson's Structure and Method in Aristotle's Meteorologica, a more disorderly nature, which is a great term for it. It can be a little specialized from time to time, but it's a wonderful piece of scholarship, and it's the main book if you're going to read about the Meteorologica. Leathennick's Aristotle's Meteorology and its reception in the Arab world is, well, it covers that topic, but it's published by Brill, so you're going to need to sell a kidney or something to afford it. Schonheim's Aristotle's Meteorologica in the Arabico-Latin tradition is also pretty good, though it's very, very specialized, and you're going to have to sell another kidney because it's also by Brill. That's 2 kidneys we're already down on this episode. Also worth checking out is the edition of William of Morbec's translation by Gudrun Willem Diem, which also situates the text in the European High Middle Ages, and thus in the very conditions in which European alchemy would develop. Again, it's by Moritz Siebeck, which is just another German version of Brill, basically, and I think it costs like $300, and I'm all out of kidneys. But more on alchemy to come. Until then, I'm Dr. Justin Sledge, and thank you for watching Esoterica, where we explore the arcane in history, philosophy, and religion.